Hello, one and all. Welcome to Discovery Science Discussion Forum. I will discuss all the science chapter here, and overall science we have 23 marks on physics, and 22 marks comes from chemistry, 23 marks from biology, and zoology and astronomy, and just will get 7 marks. And DS science is about 75 marks. 25 is regarding practical, and overall marks distributions I have made over here. Theory 75, practical 25 marks. General science questions are divided into 4 groups. You will get group A, group B, group C, and group D, where we get the mixture of physics, chemistry, biology, and geo and astronomy. Group A also consists of mixture B and C and D, all the groups. Generally in group A it contains 1 marks, group B consists of 2 marks, group C consists of 3 marks questions, and a group D consists of no it based on higher abilities or solving numericals regarding problem that consists of 4 marks. One question carries the 4 marks. Here I have made the grid. See the grid over here. 5 questions from physics, 4 from chemistry, and 5 from biology, and 1 from geo and astronomy. In group A, overall you are getting 1 marks per questions, and altogether there are 15 questions, and they are divided in this way. How to distinguish this question is from physics or chemistry or biology? There is not hard and fast rule, or there is not just like an equation, but we imagine in this way. First 5 questions comes from physics, and second 4 questions comes from chemistry, and another 5 questions comes from biology, and last one questions from geo and astronomy. We believe in that way. And group B, first 3 questions from physics, first 3 questions, second 3 questions from chemistry, and third 3 questions from biology, and last questions from astronomy. Altogether you are getting 7 questions in the same way, and it consists of one question per questions. Group D consists of 4 questions, each from one group. Okay, grade 10 physics. There are 6 chapters in grade 10 physics. The first, pressure, energy, light, heat, electricity, and magnetism. Today we'll discuss about first chapter, force. And the chemistry, we have classification of element, chemical reactions, metal, acid, base, salt, carbon compound, some gases. In some gases you will learn about ammonia and carbon dioxide, and materials used in daily life: cement, glass, polymerization, soap. We'll learn about detergent, insecticide, pesticides, and regarding the chemical pollutions. In biology we have invertebrates. We'll learn 2 types of invertebrates in detail. One is about silkworm and bees. And here you can read it out. And geology and astronomy, we are going to learn about history of the earth and the atmosphere. Generally we discuss about ozone layer depletion and acid rains, or how to protect from ozone layer depletions, or what are the causative agents of ozone layer depletion. In the last chapter, the universe, we learn about star, constellations, planets, asteroids, comet, meteoroids, and artificial satellite. Generally we focus more on asteroid, comets, meteors, and meteoroids. Okay, today day 1, and things to note. Today we'll know about gravitational force, and it's denoted by W, or gravity is F, and gravity is denoted by W or F. Gravity is also force, gravitational force is also force. Both are measured in terms of newtons. And gravitation constant value, and you are memorizing this gravitation constant. Wait, let me go up. Add note, I want to use this one. Let me get the pen. Okay, I got the pen. No, okay, I got over here, but it's not green. Yeah, I got it now. I'm using green one. See here. Okay, we'll learn these things in first chapter. In this overall the chapter, gravitational constant, memorize this value: 6.67 10 to the power minus 11 newton meter per kg square. How this unit come, I will derive in the next class. And 6.67 10 to the power minus 11 value I'll discuss regarding this in the second day. Today day one, I'll just make you familiar with gravitation force and gravity. Weightlessness. Now see the gravitation force. You are learning the gravitation force for the first time. So think if there is two masses, and two masses, think this is one masses and another masses, and the distance, if the distance between them is finite, or you can measure the distance between them, then we'll get the uh, force, and this new type of force is called gravitation force. The simple definition is the force of attraction between two masses and which are separated by a finite distance, it's called gravitation force. And the SI unit of force and word is Newton. That is a simple thing. You can write the force of attraction between any two bodies separated by a finite distance is called gravitation force. Don't write here particle over here. Particles we generally refers to the small objects, so that's not better if you write the particle. But the answer is right, but don't use particle. You can do the bodies or object, whatever you like. And the mathematical formula is F equals to g m1 m2 by d square. It means that F is the constant I told just before. G is the gravitation constant, 6.6 10 to the power minus 11 Newton meter square per kg square. How this unit come, I'll discuss in the second day. And remember this value minus 11 is in power, so you should write minus 11 at the top. Now just see here, if there is two masses, if you can find the value of two masses and the distance between them, you can get the gravitation force. And another most important thing is gravitation force is the attractive force. It's attractive force. So if there is two masses, there should be attraction. Now we are going to familiar with one example. See here, Ram with mass is 60 kg and Sam 70 kg, and both are studying grade 10 and they are in a classroom. Okay, grade room, they are in grade room, in same grade room, and see, the distance between them is 2 meter. Now is there a gravitation force? Yes, there is a gravitation force because there is a mass and distance, so you can find the gravitation force. How to find gravitation force is m1 is given 60 kg, m2 is given 70 kg. Just m1 means, why I am not writing m1 in this way, just it is a denotation of two masses. How to denote two masses? Just I am writing m1 and m2. And if I write m2, denote m2 in second masses, you might think m is square, so you might get confused. So while denoting, we'll denote m1 at the suffix, yeah, at the base. M2, it means the first mass, it means second mass. 70 kg, distance between them is 2 meter, and just 60 kg is here, 70 kg, distance between them 2 meter. Just you know the memorize this formula, F equals to g m1 m2 by d square. Now put the value of g, you know that one, 6.67 10 to the power minus 11. You should memorize that value. And for the mass, it is given 60 kg, 70 kg divided by 2 square. Overall you are getting this value. Now think about this value. This is attractive force. Two persons are attracting with each other, but the force is very small, that is negligible. 10 to the power minus 7 is very small. This value is very small, so they are not attracted. It is negligible, but it is significant in case of the force of attraction between Earth and the Sun, and in a case of heavy masses. Okay, let's go down. Now we are learning next thing, what is gravity or weight. You have written the formula W equals to mg, that you say it's a weight. Now referring to the gravitation force, take as a big object, this is a planet. I'm considering this as a planet, and a small object over here, this is small object m, and this is a planet capital N. Now the force of attraction between this small object and a planet, the force of attraction between two masses separated by distance is the gravitation force, and the gravity is a special case of gravitation force. It means that the force of attraction between the planet and a small object, and this always small object always falls towards the center. For example, let us go to the previous slide and make it rough. Okay, I'll make it rough. This is a planet, and think our small object over here, and it always tries to fall towards the center. Keep one object over here, and it will also fall always towards the center. You can view this. You are outside the earth and you are viewing such image, not sitting inside the earth. You are outside the earth and you can view in that way. If object is over here, it will fall towards the center. So force or gravity acts towards the center. So what you can write, the force of attraction between object or an object, you can add and with a heavenly object or planet towards its center is called gravity. The force of attraction between a small object with the planet towards its center is called gravity, and the formula equals to gravity is unit is Newton. Mathematically you can find gravity equals to G. Now what is the mass of the bigger mass is capital M, what is the small mass is small m. We are going to find the force of attraction between, let me change it, this is one mass, okay, and this is the bigger one. So we are finding the distance from the center. Always we take the center, this distance we consider r, and might be this distance might be smaller center of this object radius might be smaller than the radius of planet, so just we are writing r square, that is G. I need to write it here, it's not clear, that's why G m is capital M and is small m. Capital M refers to mass of planet, this is mass of object by r square. I think it's clear now. Okay, let me read, okay, down. Gravitation constant value, let me erase this, you know, 10 to the power minus 11 Newton meter square kg square, because you have mug up this formula, I have told you before. So mass, keep m equals to mass of planet, m is the mass of object, r is the radius of hint. The distance from the center of planet to the center of object should be taken here, but the center of object is very small, that might be 1 centimeter, 2 centimeter, and the radius of the earth is 6.4. Radius of the earth is, let me write it here so that you can view, it's 6400 kilometer. So that distance might be neglected, so we just take r and weight equals to mg. Now from here it is clear that you understood one type of force, that is gravitational force, and another type of force, that is gravity. Now concept of gravity I have made it clear. This is the planet, and who is making the figure is not the person who is sitting on this planet, who is viewing outside from this planet. Okay, this is the earth or any other planet, this is the mass m. Okay, here is also all, this is not a vacuum, this is all, it is not empty. All masses are over here and outside till this is the, we call the surface, we call this as surface of planet. Let me write it down, SURFACE is surface, so this is surface of planet. Now the weight or force or weight, F slash weight equals to G m by r square. Okay, how r square, just I am using the gravitational force, G mass 1, this is the mass 1, attraction between the planet, and small m, the attraction force, two masses, mass of planet, mass of object, and r square. I have taken the r square, but I think you understood. This is the weight and on the surface. Now take the correct answer. Here are some questions. The force of attraction between sun and earth is called, we know it's clearly, sun and earth means gravitational force. The force of attraction due to earth and moon, it is also gravitational force, because a too heavy mass occurs over here. The what force causes tide on the ocean? Okay, tide on the ocean is due to gravitational force. Yes. Why? When the moon approaches near the sun, near the earth, this is the moon and this is the earth, when they approach with each other, when they are near, and there is attractive force. Since attractive force, it will attract the water. Why it will not attract the land? Because land's intermolecular force, we call the intermolecular force. There is one force named intermolecular force. It means that water is made up of water molecules, that is called intermolecular force. And land is also made up of land, small type of molecules of land, so there exists intermolecular force between land or soil, intermolecular force between the water. Since the intermolecular force of water is low, So during the force of attraction, water are raised high, and again it will fall back, and again it will if it is raised high and fall back, and again it will smoothly it will go in this way. So tide will occur. It will go up, and again it will come sorry, let me erase this. In this way it will if the force attraction, the water is over here, think water is over here and water is pulled up by this much due to force of gravitation, and again it will fall back, and again it will go up, fall back, and it will slightly decrease. So in this way tide occurs. It's not a one molecules of water, a large mass of water are raised up and down. So the tides might be dangerous. It might tides are dangerous, yes. Let's go down. The force of attraction between the apple and the surface of the earth, earth, and the force of apple is over here. So it's an example of gravity. Which of the two, in case of tides, of the gravitation force between the moon and the earth? This is the two. Yes. During the force of which of the flowing medium is affected? What is affected? We know that one. Now you have to write down the value of gravitational constant. This is your homework, and you have been learning. I have told you to mug up 6.67 into 10 power minus 11, and unit you can write Newton meter square per kg square. How I am writing the unit, I can tell you. This is the easy thing. Just think here. You know G equals to, sorry, F equals to G m1 m2 by d square. From here you get G equals to, now, or this is use your mathematics. G equals to, you will multiply this two, cross multiply, because it's down over here. Just F means just do cross multiply. Let me change my ink. 7 minutes has gone, so we should not make our lecture long. You will get G m1 m2. We are about to complete today's class by fd square. Okay, now it's easy thing. Now just get the value of G by using your solving equation in terms of mathematics. You'll get fd square. Fd square equals by m1 m2. Just m1 m2 refers to mass 1 and mass 2. Don't confuse it. M power 1, or you should write m1 m2 in that way. Just it is at the base. It refers to the two masses. M1 refers first mass, another second mass. Now just here force unit is Newton. You can write your Newton, and d square means meter square, and m1 m2 means you can write your kg square. Now let's go down. What is the questions? Yeah, if the mass of the sun is 2 into 10 to the power 30 kg, it's the actual mass of the sun, and that of earth is 6 into 10 to the power 24 kg. If the separation between their center is 1.8 into 10 to the power 6 kilometer, calculate the gravitational force between them. Yeah, in this case you will get 10 to the power 22, nearly 1022 newtons. So it means that this is the sun, and if this is earth, they are attracted. Why it doesn't attract? You might get a questions, and you can say there is attractive force, the earth is not moving towards the sun. Let's go down. You can solve this question. How you can solve this question is, center of earth is this, then you can just convert. You can write m1 equals to, just write m1 equals to 2 into 10 to the power 30 per 30. Okay, if I take kg, I need to draw this figure. We have 20 minutes. We should not make the video long. Let us complete it fast. uh, okay, see here, mass equals 20 per 30 kg. I have mentioned it. And empty is 16 to the power 24 kg, and distance is in kilometers, so you should use your time, okay, to convert it into meter, multiply by 1000 and plug in all those values, because force is given by this formula. You will get the value. I have done completely over here. You can see mass d is given here, and we know g. And also, let me go up and let me see here it notes. Okay, now we can write here c and just put in those value. You will get this one. So it's quite not difficult one. Just have made this figure to find it out. Now I think we are at the end of this today's class, and let's go down. Okay, let's go down. We have drawn this conclusion to be noted. Yeah, what we learned, we are familiar with now gravitational force and gravity. Gravitational force means if there is two masses, then there occurs a gravitational force, and gravity is the example of our special type of gravitational force between a heavy object or a large mass and a small object on the surface of those objects, just like a planet and an apple, or planet and a pin, or planet or a man or a house, whatever. But there should be a big planet, or a big you can see the moon also, a satellite, natural satellites and object. That is the case of gravity. And solve numerical, we could solve the numerical regarding the gravitational force, and we can solve the numerical regarding gravity too. And universal gravitational constant, we mock up the values of this one, and we also know the units how it come, and value also we knew. And how tides are occurred. Tides are, I told you that when moon approaches near the earth, why gravitational force is more pronounced on water than land? Both questions are same. How tides are occurred means due to the force of attraction, or during force of attraction between moon and the earth. It means that when moon and earth approaches, when they are near to each other, the force of attraction will be more. So water get more affected than land, because intermolecular force, we call intermolecular force, between the water is less than the land. It means that water molecules is less, so the water, large mass of water are generally are raised up by the gravitational force. So in this way the tides are easily pulled by water. How tides are occur? When the sun when the moon and the earth are approach near to each other, and there occurs a force of attraction, or the moon attracts the water on the surface of the earth, so it will raise high and the tide will occur. Thank you. This much for today. I have separated 3 4 or 5 days uh, to complete the first chapter. Thank you for listening.